had a lot of people ask me how I design and produce reproduction battery covers. So I decided, why not produce a video, show how the whole process is done from start to finish, and that includes designing one. What you see here on your screen is a McMichael 367 portable radio, probably from the mid-1930s. There's somebody in Britain who wants me to design the high voltage battery, and I just so happen to have information on which one it needs. So let's go ahead and pull out the materials we need, and we'll come up with a design from start to finish. Now, looking through the information about this radio on radiomuseum.org website, which I highly recommend because they've just about got every radio you can think of, and it's got all sorts of information. It uses a 2-volt accumulator battery, and this is our what they call an HT battery. I hope this can focus in. It's called a Drydex H1018. That's what we need designed. It's 108 volts. So next thing I'm going to do is I'm going to go through Paint Shop Pro. I've got the same information here. And I looked through my catalogs, and I wasn't able to find a 1018. That's the pre-war version. However, over here, the modern equivalent is an H1044. So, what I'm going to do is I'm going to go to my battery folder. We're going to go to battery data, and then we're going to go to the British battery reference file. He wants it as an X side. So, here is a 1949 Drydex battery catalog that I got, and I went and scanned it in. And what we need to do is find their selection of what we would call over here B batteries. They call them high tension batteries. And what I'm looking for are the measurements for the H1044. And looky here, I'm blowing this up right now. 1044 shows we need it to be 10 inches by 5 inches by 2 7/8 inches. This is the voltage, 108 volts. And I'm going to draw a line across just a standard 8.5 by 11 sheet of paper, like so. Now, our measurements: 10 inches, 5 inches, 2 7/8 inches. I mark those out. Here's 10. Here's 5. And then there's 2 7/8. So we got 2. And so that's 1, 2, 3, 4, 5, 6, 7, 7/8. Fine. Now normally, if these were all even numbers, I wouldn't have any trouble plugging it into Paint Shop Pro, which is what I normally use for my artwork. However, we have 2 7/8. It's a fraction. Normally I don't like messing with fractions because in order to plug it into Paint Shop Pro it has to be decimalized. So I don't even bother with inches. What I do is I go to the millimeter side. I have my inches laid out. So I'm going to go in, make sure we're nice and even. I'm going to line up what these are in millimeters. In this case, 2 7/8 It's roughly 72 millimeters by 1, and then we got 126 for the 5-inch part, and then for 10 inches 253 millimeters. Okay, there we go. So we got 126 by 254. That's what I'm going to plug in here. So we go into new, set this to centimeters because it doesn't do millimeters, but you know, big whoop. All you got to do is put a decimal place in. So our length, that's going to be 25.4 centimeters. Our height, 12.6. There's our face. Now what I do is I make it green like that. I've made all my dummy covers green. Don't ask me why, that's just how it is. Then the other thing I'm going to do is I'm going to resize this to about 400%. The idea is the bigger you make it, when you get ready to print it, the better the resolution is going to be. You're not going to have any fuzzy or jaggy edges or anything like that. I won't say it's going to be camera ready, but darn near it's going to look a whole lot better. So this is done. Now, as an added bonus, we're going to go in and we're going to say that's 254 by 126 millimeters. Alright, so this is the face. We're done with it. Now we're going to make the side. The height is 126, so we want to use the other one. Actually, we want to do 254 by 7.2. There we go. This is our side. It's the longer of the two. Last one. This is going to be the narrows. This is the smaller of the two sides. So we're going to go here. Instead of 25.4, we plug in 12.6. There's the side, the narrow. Color it. Increase it by 400%. Now, plug that in. There we go. These are the ingredients with which to make our cover. Now comes the fun part. We've got to take this and put it on what would be a standard 8.5 by 11 sheet of paper. In this case, it'd probably be an A8 also, but for right now, I'm going to put it on 8.5 by 11 because that's what we work with here in this country. A8 is a little larger that they use in Britain. So if I work with smaller stuff, that's all the better. It's if what works with 8.5 by 11 is going to work with A8 over there, no trouble. So I need an 8.5 by 11 sheet of paper. So we start with new. We switch over some centimeters to inches. 11. The height 8.5. Will be a standard white sheet of paper. There's our paper. Since these have been blown up to 400%, we need to do the same thing with the paper. Boom. There's our paper. Now the fun part begins because we've got to find out what is going to fit with all of these onto this sheet of paper. And that's going to dictate how I'm going to put this together. Because it's not all going to fit. What I'm hoping for is to be able to put a face and a narrow together. I'll be lucky if I can get a side in there. I doubt I'm going to. This is a very big battery. So here's what we're going to do. We'll take a face. We'll copy it. Let's see how far we get. Paste as new selection. Wow, that is tight. So it's not going to be a narrow. It's going to be a face and a side that's going to fit because I've got just enough space on either side to fit. So what I want to do is I want to put this, roughly about right here. I'm now going to enlarge this, because the next thing I'm going to do, I'm going to take this side and I'm going to paste it in. I want to see how this is all going to dummy out. So let's blow it up. Let me take it down maybe 1 or 2. No, you're going backwards here, honey. Get back here. There you go. Alright. We're going to paste as new selection. Alright, let's see how thick that is. Ooh, I don't know. That may not work. That is not going to work. It's too big. Alright, well that tells me this is not going to work. However, I still can work with this. This is how we're going to do it. Since this is not all going to fit properly, what I can do, let me delete this out. We'll take our face. We'll put it here in the center. What I can do is I can put a flap here. I can put a flap here. Well, let me see. A flap here and a flap here. Then the face will attach to the sides by way of this would be the top, another one of these will be the bottom, and it'll have a flap to hold these in place. So then the narrow will also have flaps. This will carry the brunt of holding it together. The side won't have any flaps at all, and the narrow will have 2 horizontal flaps, and it should all come together. And here's the finished product. All the points are in place, ready to go. Your negative to the 108 volt section here pretty much matches up with what's on the original. So this is roughly what the original layout would have been. Now, this is now the time that we save this as, let's get that BMP out, the Drydex 1044. But we're even going to go one step further. We're going to say this is the top, because the bottom, of course, is not going to need any holes. So on the bottom, we just delete that out, and we're ready to go. The next thing I'm going to do is start looking through my graphic standards and seeing what I can come up with in terms of lightning bolts and such. It looks like this is an older style, so I may have to come up with a different graphic. And I'm not going to bore you with that, but I will show you the finished product of the graphic lightning bolts and such once I get them done. Alright, here's the finished product on the screen. I've now switched over. This is the face side, by the way. I switched over to a program called Earfan View, IRFAN as in November, View. It's a free printing program. It's a free graphics program for the most part. Is very accurate. I use that as the printout because, if you remember, I said this was 254 by 126 millimeters. Well, if you go here and you go to print, you can plug that in directly. So, like for instance here, I'm going to go in here, 25.4, and then the rest of it follows along. Now it says 1556 here, you might notice, but that's because I've got those 2 flaps in there, so that adds to it. So now, all I have to do is print that up. Well, I've already done that. I'm going to show you. Here we go. How about some light? That's more like it. Here's the face. This is the top. There's the bottom. Here are the sides, and you might notice that they, if you remember what they looked like from the original, I've got them as close as I could with them. Now, I did make a little mistake. I didn't get calculations correct on my narrows. Had it wrong. This is too small. So I went ahead and realized I needed flaps on the tops and the bottoms. And if we go here side by side, everything matches that way. And then if we go up here, and that's correct too. So now, usually I don't do dummy covers in color, but I want you to see what they look like from here. I'm sorry it's dark in here. I don't have a light on back behind me, so that's why I'm using this one. Most of my movies, unfortunately, look like they're out of a bat cave. I have to apologize for that. But at this point, I wanted to show you what a finished product would look like. So instead of doing a dummy cover, which would be in black and white, I decided to do a full color one. This is what it's going to look like for the most part. So next thing I'm going to do is piece everything together, and I'm still not finished yet, because what I'm going to do is I'm going to number these to which phases go here, which sides go here, and whoever gets this will be able to put it together like a jigsaw puzzle, and when they get done they'll have a complete box. Okay, so here is the finished product. There are 5 pieces here, and then the 6th one is over here. So what I'm going to do is I'm going to number these. What I usually do is I go from the left to right. 1, 2, 3, 4, 5, and then this will be 6. Now to do that, I'm going to number these sides and edges here. Since this is going to be 1, that's going to match up to 2, so 2 will be here. 3 will be labeled here. 4 will be labeled here. 6 will be labeled there, and I will do that and so forth. And now I'm going to start putting the whole thing together, and this will give you an idea of how big the battery is going to be. And I might add, after I've numbered these, I can then take a look at my other ones that I've done on the computer, and I can label them as such, which means I'll have to make another one of these on the computer, which is nothing, and just copy it, and they will be numbered 1, 2, 3, 4, 5, and then next to them we'll have the measurements of what they're supposed to be. And here's the finished product. Shows the volts. The price, which I can't remember how that works. Somebody in Britain will have to tell me how that worked. That was the older system before they went to decimal in the early 70s. And my hand is shaking like crazy. Also here on the sides, basically the same thing on this side. And then the bottom, that normally was just left blank. But this is the high tension battery that he needed. And each one of these would be a tap. This would be your negative lead, and then your earliest one goes to 45, 54, 63, 99, and then 108 volts total. But from start to finish, that's how I come up with the batteries. I won't go into the other part because that would be involving the cradle and the mechanics, but you get the idea. It'd be a bunch of 9 volts tapped at those certain voltages, or as close as I could get to them. And it would be a wooden box or masonite all butt jointed together. You've seen that part. But from start to finish, this is how I do those batteries.